If you've been lifting in the gym for a while, undoubtedly you've at some point lifted two different cable stacks with apparently the same amount of load on them, and yet your experience of the stack is very different. Oftentimes some cables feel really, really heavy, right? Let's say we have 100 pounds, feels really heavy. And then other times we have 100 pounds on the stack and it feels really light, feels really smooth. So today we're gonna talk about, in very simple terms, why that is. And I'm gonna give you a few key takeaways so that you can identify which cable machines in your gym are going to tend to feel heavier and which are going to tend to feel lighter. So imagine a scenario, just to start off, where we have two cable machines, both of which actually have 100 pounds. So we're ignoring like, okay, what do the machine manufacturers actually label on the stack? Just imagine we have two stacks and there are actually 100 pounds on either one of them. A lot of times you'll see a stack like this, which just has this little dinky little attachment thing, and a cable comes right off of the stack, right? And I'll put videos here so you can see an example of that as well. And oftentimes when this is the case, this cable basically goes up, it redirects to a number of different pulleys, all of which don't really do anything to the cable, but just redirect the force. And eventually it ends up in your hand via a handle. And when it comes out the other end, you actually grabbing on the handle will equal 100 pounds or so. At least just in terms of, if you're holding the weight still, the weight's not moving, 100 pounds. But a lot of weight stacks have something like this, where they have that same little attachment thing, right, coming off of the top of the stack, but instead they have something like a pulley, okay? Now, again, the function of a pulley is just to redirect force, but oftentimes when this is the scenario, one side of this cable will attach to like the bedrock of the machine. In other words, the machine will be in essence holding half of the weight. So on one side of this stack, you imagine this thing is just pulling down right now, it's just hanging here with 100 pounds force. You end up with 50 pounds on one side of this cable, and on the other side of this cable, you end up with the other 50 pounds to make 100. And eventually that comes into your hand. And so what your hand experiences with the same 100 pounds, just because you added a pulley, and specifically where you attach one side of the cable, now you're lifting 50 pounds instead of 100. And guess what? Some of you have probably seen these types of things, except with two pulleys, right? So instead of one pulley, there's like another pulley that's sort of layered here, and there's another cable that's sort of doing a similar thing, right? And both of these eventually come out to a single handle, and in that particular instance, what would happen is each of these little lines would be carrying 25 pounds, and so you would end up with 25 pounds in your hand. So there could actually be a situation wherein, given the appropriate setup of pulleys, you could, in essence, cut the weight that you're actually lifting compared to what is on the stack and divide it by 4, right? And so this is like, for example, what a lot of people use in construction, right? Because in construction and construction-related jobs, you're lifting very, very heavy objects, right? Or you have to. So you have to find ways to give yourself a mechanical advantage over the load, so that what you're actually experiencing as the load is less than what you're, in reality could be lifting. Now let's step out of that for just a second, okay? And let's imagine that we have one pulley on here and no pulleys on here. But imagine that the manufacturer has accounted for this whole mechanical advantage thing. So imagine that, in fact, in either case, you actually do have 100 pounds out in your hand, right? Which, in terms of the weight on the weight stack in this particular case, it would need to be 200, right? An actual weight. So I'll put this in parentheses, but let's just say they've actually labeled it 100. So the reality is that you have 100 now and 100 now, and that's true. But you might have, let's say, 200 pounds in this stack to account for that. So the manufacturers have accounted for that. Why do these still feel different despite the fact that we have 100 here and 100 here? Well, a simple way to think about it is, if you have one pulley, let's say, attached to the cable stack, and as you pull on the pulley, just imagine a weight stack going up and down, what in essence is happening is that pulley is spinning, right? The cable is essentially rotating around that pulley. In other words, as you pull on the cable, because the weight stack is moving upward, you're in essence giving yourself a greater amount of sort of fishing line to be able to pull. And so what that means is that for every foot that you pull this weight stack, you can actually move twice the distance. Let's say 2 feet per 1 foot that this cable stack moves. And if you added another pulley on top of there, you could actually move 4 times the distance as compared to however far this is traveling, right? So if this travels, let's say half a foot, you could literally pull 2 feet in that instance to move this half a foot. So why is that important? Well, if you're pulling a lot longer distance, but the weight stack is actually moving a lot less, and in this instance, the weight stack is basically just a one-to-one motion. In other words, if I pull this a foot, this whole thing has to travel a foot. This one has to accelerate to a much higher degree, and therefore the forces associated with moving this kind of cable column, cable stack are generally much greater because of the motion-related influences. So in simpler terms, when you have, and you can all actually see this, go to your gym and test this, pull on something that has 1 or 2 pulleys, you'll move at a really far distance, and just notice how little the weight stack moves compared to this one, where in a one-to-one fashion, when you pull it a foot, it will move a foot. You'll see how much longer the distance is that this one is moving, and that results in much higher forces coming from acceleration, deceleration, and those kinds of things. So why is this important and why does this matter? Well, a lot of times, again, if you actually equate for the absolute weight in your hand, again, just if you were just to hover the weight stack, 100 pounds, 100 pounds, these ones end up feeling a lot smoother because the acceleration, deceleration effects are much lower, right? And so in other words, if any of you have ever coached, let's say a beginner client, they have a very tough time sort of controlling the influence of acceleration. And so using these kinds of machines can be very, very beneficial, especially for beginners, just to basically reduce those sort of dropping, catching, accelerating forces that, at least in people who have had potentially prior issues in whatever joint that it is. A lot of times it ends up being like the shoulder, for example, where dumbbells feel like crap to people, but a lot of times cables don't for a variety of reasons, right? One of which might be the fact that per the same distance that your arm moves, the weight is accelerating a lot less, right? Which again can just allow for this sort of smoother feeling experience, this greater feeling of constant tension on the muscle and more control overall. Now, there are many other influences to this that, number one, are beyond my scope to attempt to describe. Some engineer who's watching this, please correct me wherever I've been wrong, and I'll make future videos in terms of maybe explaining this a little bit better. But keep in mind that when we're talking about machines, right, many machines have pin-loaded features. There are many other influences within a machine that can impact what ends up being the feeling at your hand when you're pushing, or when you're pulling, or when you're doing a curl or something like that. So keep in mind that this is not the only influence, but if you're oftentimes when you're looking at cable stacks, this is a fairly reliable strategy to be able to see. And if you don't really know, like just based on the descriptions I've given here, again, go over that test of like move the handle a foot, see how far the stack moves. And again, make your decisions in terms of maybe which pulleys you want to use for different exercises, right? So for example, if you want to do like a lateral raise type motion, it might be beneficial in many instances to use a cable pulley like this. Whereas if you're doing a pull down, maybe, not that you necessarily have a ton of options, potentially where you actually want to experience more acceleration going into the top because you want to make the top harder for whatever reason, then you might want to go with something like this. So sort of different strokes for different folks and different goals, and which of these you choose should really just depend on sort of what your experience of these are. And so personally, I tend to prefer like a 2-to-1 or a 4-to-1, like when there are 2 pulleys or 1 pulley. I just like the feeling of that smoothness a little bit more for most exercises. But when I'm doing pull downs and things like that, I actually prefer something a little bit more shaped like this. So I hope this helps. And again, if any of you want to sort of comment, clarify anything, I want to make sure that I get this all right, and I'll make potentially future videos if I need to correct anything.